Hello everyone. My name is Abhishek and I'm mathematics faculty at askIITians. And in this session, we are going to this is the lecture number 2 of the chapter Applications of Trigonometry. And before we delve into the topics that we are going to cover in this session, it is very important to revisit the weightage of this particular chapter as far as board examination and Olympiad examination is concerned. As far as board examination is concerned, the weightage of this particular chapter is 6 marks. And as far as Olympiad examination is concerned, you can expect around 1 to 2 questions from this particular chapter. In boards, the weightage is 6 marks, which is same as like you can expect 2 questions from this particular chapter in your board examinations as well. Okay. One question will have more, like it will fetch you more marks, and the other one is going to fetch you around 2 marks. Okay. So we discussed this thing in our last session as well. So let's move to the topics. So the topics that we are going to cover in this session, we are actually going to do some important problems based on balloon and cloud. And let me tell you this very clearly that this topic, balloon and cloud related problem, is an important topic. Very important, I would say, if you talk about Olympiad stuff and in board examination as well. Many times problems have appeared from this particular topic. And the thing is that if you come across a problem from this topic, the problems are not going to be direct in nature, they are indirect. First you have to decode what is given in the problem, then you have to draw the proper figure, then you have to choose the proper triangle, you have to relate multiple results to get our answer. And all this is actually a function of practice. The more questions you practice, the more command you are going to get over this particular topic. Okay, so we will be covering some good problems in this session. Stay focused. Stop me and ask me wherever you feel you haven't understood anything. I'll be more than happy to explain that to you guys. Let's move ahead. All right. So what does this problem says? This is the first problem. This problem says the angle of elevation of a cloud from a point 60 meter above the surface of a water of a lake is 30 degree. So this is the cloud you have. This is the point under consideration. Let me mention it here. Okay. So this point A is acting as a cloud. Okay. This is the surface of water. This is surface of water. Okay. And this is the point under consideration here, which is D. And this is the angle of elevation. Understood? That is angle of elevation. Clear? Then what is given? And the angle of depression of its shadow. Angle of depression of its shadow from the same point in water of lake is 60 degree. So this is the angle of depression and this is the shadow. Okay. Find the height of the cloud from the surface of water. So basically we have to calculate AB because AB is the height of cloud. What do we have to find? We have to find AB because AB is actually the height of the cloud from the surface of water. And what is the interesting thing to note here? Interesting thing to note here is CD is given 60 meter. And because CD is 60 meter, then it is very clear this value OB is also going to be 60 meter. All right. So let me write it here. You have CD. Here you have OB, that is same as CD, and both of them will be equals to what? Both of them will be equals to 60 meter. That's the first point. Also, we know that whatever the height of the cloud will be above the surface of the water, the same distance of the image will also be there from the surface of the water. True or not? What I am trying to say is if you are talking about, let's say, plane mirror, the image that is formed by plane mirror, then the distance of the object from the mirror is always same as the distance of the image from the mirror. So here, because this distance AB is equal to 60 plus H, then this distance BA dash that you have, this has to be 60 plus H meter, because otherwise this situation is not possible, right? So let me write that result also. What do we have? We have AB that is same as AB that is same as A dash B. Okay. AB that is same as one second. A dash B, and both of them are equal to 60 plus h meter. Understood? Now we have two right triangles. We are going to use the concept of trigonometry in both of them. So first I am considering triangle ADO. So in triangle ADO, if I calculate 10 of 30 degree, okay, if in triangle ADO I calculate 10 30, then that is going to be capital H over OD. Clear? 10 30 is 1 by root 3. So you have 1 by root 3 is equal to capital H over OD. So this actually help us to find out the value of OD in terms of capital H. So OD is capital H root 3. This is an important result we got here because we will be using this result in like the next when we will apply the concept of trigonometry in the other right triangle, we are going to use this particular result. So we got OD is equal to capital H root 3. Now we are going to move to triangle DOA dash. Okay. So in triangle DOA dash. Understood? So if in the triangle DOA dash, I calculate 1060 degree, 1060 degree will be A dash O upon OD. 1060 will be 1060 degree will be A dash O upon OD. That's what I have. We all know 1060 is root 3. A dash O. What's the value of A dash O? A dash O is actually sum of A dash B plus BO. A dash O is sum of A dash B plus BO. And OD we already calculated here. You can see that is capital H root 3. So we are going to put it capital H root 3. All right. So if you simplify it further, you will be getting 3 capital H. Here, what is A dash B? A dash B, if you look at the figure, A dash B is 60 plus H. You can see here that is 60 plus H, and this value is 60. So the complete length is going to be 60 plus H plus 60. Okay. We will have 60 plus H plus 60. All right. You can transpose that capital H to the other side. So what will you get? You will get 3 capital H minus capital H, that is equal to 120. So what will you get? You will get 2H is equal to 120. So what is the value of capital H we are getting? Capital H is equal to 60 meter. All right. So we got this point, like we got this as one of the value. So since we got the value of capital H, what we were supposed to find out in this problem? In this problem, we were supposed to calculate, or we were supposed to find out AB, right? And AB is nothing but that is the sum of capital H and 60. So what is the value we will get? Therefore, AB, which is equals to, I'm writing here, right? Therefore, AB, which is same as height of cloud from surface of water. Height of cloud from surface of water. From surface of water. That will be equals to what? That is going to be equals to capital H plus 60 meter. Okay. Capital H is 60, you can see. So that will be 60 plus 60 meter. Understood? And 60 plus 60 is going to give me 120 meter. So 120 meter is the answer to this problem. That means the height of the cloud above the surface of the water is equals to 120 meter. That's the answer to this problem. So you can see the problems are not direct, but yeah, at the same time, they are not difficult. It's about the clarity of concept. If your concepts are clear, if you are good with the calculation part, I believe you can easily do it. All right. I hope this problem is very clear to everyone. You can go through it. I'm giving you 30 seconds. And if you have any doubt, ask me before we move to the next one. All right, no doubt. Okay. So here the solution has been given for your reference, guys. You can go through it, and this solution like helps you a lot to know like how you have to actually present the answer in your examination. Make sure that you follow this pattern only while writing your answer in the examination, because presentation matters a lot when it comes to school examination especially. Okay, answer is 120 meter only, the same as we got. All right, now we have one more problem. What does it says? Let us read it. It says a balloon is connected to a meteorological ground station by a cable of length 215 meter. Okay, inclined at 60 degree to the horizontal. So this is actually angle of elevation, and determine the height of the balloon from the ground. Assume that there is no slack in the cable. So basically in this problem, we are provided that this length that we have, AC, that is equal to 215 meter. All right. And this is the balloon you have. You can see this is the balloon that we are talking about. Okay. And they are asking you to find out the height of the balloon from the ground, assuming there is no breakage in the cable. So you have to actually calculate this AB, and I'm going to call it H. Okay. So you have to find, what do you have to find? You have to find AB. Okay. Now this is quite easy problem. Okay. So first let us assume, let AB is equal to H meter. AB is equal to H meter, right? Now the thing is, we know the hypotenuse of this right triangle ABC. We have to find out height. So now we will look for the trigonometric ratio which involves height, that is perpendicular, and hypotenuse. So there are two trigonometric ratio which involves perpendicular and hypotenuse. One of them is sine, and the other is opposite of that, that is cosec. You can use any of those two results. So if I use sine here in this triangle, okay, in triangle ABC, if I calculate sine of 60 degree, what will I get? Sine of 60 degree is perpendicular by hypotenuse. So I will be getting AB by AC. We all know what sine is. Sine is root 3 by 2, right? What is AB? AB I have to calculate. What is AC? AC is 215, correct? So what will I get? I will get capital H is equal to 215 root 3 by 2. You can simplify it more by substituting the value of root 3, and that will give you your answer or the required height in this problem. Okay, this was super easy. It was just like you should be aware of what you have to find. You should be able to find out, you should be able to extract out what information is given, and then you should be able to determine which trigonometric ratio is going to fit here in this problem. If you are able to determine all these things, then you are done with this problem. Nothing else is there. Go through it. Let me know if you have any doubt before we move to the next one, guys. All right, done. Okay. See, you can go through this solution again. They substituted the value of root 3. After substituting the value of root 3, if you simplify it, you will get 186 meter as the answer. That's it. Like, the approach is pretty simple. This is very important problem both for competition. This is very important both for competition as well as for your school examination. Okay, this is very important for both. And let us see what is given, what we have to find out here. All right, check out. We are given if the angle of elevation of a cloud, okay, from a point H meter above the lake is alpha. Okay, so basically this is the cloud you have. So this point D is depicting the position of cloud. Okay, and the angle of depression of its reflection in the lake is beta. So this is the reflection of the cloud. Okay. That is reflection of cloud. Okay, reflection of cloud. Okay, and this is angle of depression. Then they are asking, or they are saying, prove that the distance of the cloud from the point of observation is this. So that means the distance of the cloud from the point of observation, because this is the point of observation. This is cloud. I have to show that the CD is equal to this particular value, that is 2h sec alpha 10 beta minus 10 alpha. Check out. So what do I have to show? I have to prove the CD is equals to 2h sec alpha upon 10 beta minus 10 alpha. Okay, that is what we have to show. Let's see how we can do it. So again, because the reflection, the distance of, like, that's a property of plane mirror, which says that the distance of object in front of plane mirror is always same as the distance of image from it. Okay, if you consider that property, according to that property, this value that you have, capital H plus a small h, this will be same as this distance, which is capital H plus a small h. Okay, so let's see what can be done. So we have two right triangles here. Okay, so we are going to consider them one by one. In triangle CDE, if I calculate tan of alpha, what will I get? Tan of alpha is going to be equals to DE, which is perpendicular upon base, that is CE. Okay, so what will I get? Tan of alpha. From here I can calculate CE. What will be the value of CE? CE is going to be capital H upon DE. And what is DE? DE is capital H upon tan alpha. That is the value of CE which I got from the first triangle. That's an important result. Okay. Now what do I have? I have one more triangle. Let us move to that. In triangle CED dash. Okay. In triangle CED dash, if I calculate tan of beta will be what? That is perpendicular. So perpendicular is capital H plus a small h plus a small h. So capital H plus a small h plus a small h upon base, which is CE. We all know what is CE. CE is capital H tan alpha. Okay. So what will I get from here? I will be getting tan beta CE, that is equal to capital H plus 2 times of small h, right? That's what I'll get. So what do I have? I have capital H is equal to tan beta capital H upon tan beta, because capital H will be tan beta CE, and CE is capital H by tan alpha. So capital H will be tan beta CE, which is H upon tan alpha. Okay, minus 2 times of small h. That's what I have, right? Or because I am interested in finding out the value of capital H, so what can be done here? We can write it like this. Or one second, this is tan alpha. Okay. Or you can have capital H tan beta upon tan alpha. Okay, minus capital H, that will be equals to twice of a small h. You can observe from here. Okay, I transposed this capital H that we have on the right hand side, and I transposed 2 small h to the other side. So I got capital H tan beta by tan alpha minus capital H is equal to 2h. Okay, now I can take capital H common because I am interested in the value of capital H, and take LCM. So if I take capital H common, I will be getting tan beta minus tan alpha upon tan alpha. Okay, and that is equals to 2 small h. So what is the value of capital H? Capital H is equal to 2 small h tan alpha divided by tan beta minus tan alpha. This is one of the very important value which I got here, as I will be using it as I will be using it to get my final result. I'm going to name this result as, let's say, result number 2. Okay, so we got the value of capital H. We are interested in the value of CD here. So I know capital H, which is the perpendicular in this triangle CED, and I want hypotenuse, so I can use the formula for sine alpha, because sine alpha is perpendicular by hypotenuse. So in triangle CDE, in triangle CDE, if I calculate sine alpha, what will I get? I will get capital H upon hypotenuse, which is CD. Okay, hypotenuse, which is CD. I want the value of CD. So what will I get? I will get CD is equal to H upon sine alpha. We know the value of capital H, so I'm going to put it here. So what will I get? I will be getting CD is equal to 1 upon sine alpha. And what is capital H? That is 2H tan alpha upon tan beta minus tan alpha. That's what I have. Okay. Now I can break this tan alpha that I have in the numerator in sine and cos, so that we can cancel this sine alpha. So what will I get? I will get CD is equal to 1 upon sine alpha multiplied by 2H. Tan alpha can be written as sine alpha by cos alpha. Okay. And in the denominator, you don't need to do any change. You can keep it as it is. So it will remain tan beta minus tan alpha only. Understood? So this sine alpha and this sine alpha will get cancelled. So 1 upon cos alpha can be written as sec alpha. So you have 2H sec alpha. Understood? That is divided by tan beta minus tan alpha. And that is exactly what we were supposed to show in this problem, right? So I understand when it comes to this problem is not direct, and it is not supposed to be direct, as it's a good level problem. You can expect these type of problems in your Olympiad and all. But yes, it's not impossible at the same time. It's just a matter of practice. If you practice it again and again, I'm sure the same problem will start appearing easy to you guys. You can go through it. Ask me any doubt if you have before we move to the next problem. Okay, done. All right, check out. You can go through the solution as well. They have done it in the exact same way, and it is more clear as it helps you to know like how you have to actually write in your examination. This will help you out with that. Okay. So now this is again a very important problem for Olympiad as well as school. I think this problem has already appeared once in a school examination as well. Okay. So what do we have? This is a very important problem. Okay. What does this problem says? This problem says a spherical balloon of radius r, this is the balloon, subtends an angle theta at an eye of observer. So this is theta angle, you can see. If the angle of elevation of its center is phi, this is phi, okay. Find the height of the center of the balloon. So basically we have to calculate this small h. Okay, that's what we have to calculate. So let's see how we can do it. So this smallest that you have, this you should keep in mind, because I have seen kids making this mistake or this blunder many times. What is that? What they do generally is they find or they calculate the answer in terms of any unknown which is not given in the problem, or in terms of the value which is not a part of the problem, which is an incorrect approach. Here they are asking you what is the height of the center of the balloon. That means they are asking you what is a small h. So your small h that you have, it should be in terms of r, theta and phi only. There should not be any fourth value. Okay, because r is given to you, theta is given to you, phi is given to you. Your answer should be in terms of that only, should not include any other stuff. Okay, let's see how we can do it. Okay, so we all know one thing, right or not? Okay, can I say that OP that you have, it will be perpendicular to AP, because this AP that you have, it is acting as a tangent to circle, right? It is acting as a tangent to circle. And we know that tangent and radius, like tangent is perpendicular to radius at point of contact. We all know that, right? At point of point of contact. Okay. So that means this angle is going to be 90-degree. Clear? Is that clear? Yeah, what happened? Also, because this triangle that you have, let me join Q to O. Okay. So also these two triangles that O by triple S rule, right? Why triple S rule? Because these two are the tangents drawn from external point. So they will be equal. I'm writing the reason here as AQ and AP. They will be equal tangents from external point. Tangents from external point, right? And what else do we have? AO is common. AO is equal to AO common. And what do we have? You have OQ is equal to OP. Okay. Radius. Okay. Because these two are same. So can we say, because these two are same, therefore it can be said that angle QAO will be same as angle PAO, and both of them are going to be theta by 2. Right? Clear or not? Now in triangle AOP, if I calculate sine of theta by 2, what will I get? Sine of theta by 2 will be perpendicular upon hypotenuse. Perpendicular is R and hypotenuse is OA. Clear? That's what I'll get. Let me call it our result number 1. This is our result number 1 we got. The value of sine theta by 2 is R upon OA. Now I am going to consider which this triangle AOB, as triangle AOB includes H, which we need to find out. It includes AO, whose value we already know. Okay. So I am writing here, guys. Okay. In triangle OAB, if you calculate 10 of 5, okay. So 10 5 will be what? That will be small h upon AO, right? That's what I'll get. Now what I can do is I can divide 1 by 2, or I can divide 2 by 1, whatever you want. So let me divide 2 by 1, okay, because I want h. So what will I get? I will get 10 phi upon sine theta by 2. Do not cancel 10 phi and sine theta because the angles are different. And on the right hand side, what will I get? I will get h upon AO divided by R upon AO. AO and AO gets cancelled. So what is the value of h we will get? The value of h you will get is R 10 phi, okay, R 10 phi upon sine theta by 2. Now you can see this value of h which we got. It is in terms of what has been provided to us in the problem. It does not include any additional stuff or any additional value which is not a part of this problem. This is something which you have to keep in mind. Or in any case, let's say you are introducing any let's say unknown or any term from your side, then it is like you have to make sure that in your final result it should get eliminated, it should not be there. Because here we got the required value, which is a small h in terms of R, the radius, which was given to us, in terms of phi, in terms of theta, which were again provided to us. So you can say this is your final answer, right? So this is something which you have to keep in mind. If you see all the problems that we have done till now, it's only about relating the different results. And believe me, the more you practice, the more you make mistake, the more you overcome those mistakes, you will get good in this topic. And if you'll get good in this topic, automatically your score, be it in board examination, be it in competitive examination, is going to improve automatically. All right, go through it. 30 seconds. Again, if you have any doubt, ask me. All right, done. Excellent. You can see this solution. You can refer this solution for your uh, oh, 1 second, guys. Here we should have cosec. One mistake. Here we should have cosec. Cosec 5. This should be cosec. This should be cosec or sine, you can say. Okay. So this should be sine because we have perpendicular by hypotenuse. No, this should be sine phi. That should be sine phi. Okay. And this should be sine phi. You can also write it as r sine phi cosec theta by 2. Understood? That was a error. Okay. Because the formula that we used was perpendicular by hypotenuse. So keep that in mind that you should use the appropriate identity. Okay. Done. That's it, guys. Okay. All right, let's move ahead. You can refer this solution for your help or to go through like how you have to present this answer in your examination. You can refer this part. So, like what all have we covered today? Like today session was actually meant to discuss some problems based on cloud and balloon, and especially the last two problems are super important. If you haven't understood it at the one go, make sure that you revisit them and practice more and more problems from any good resource based on cloud and balloon. The more problem you will practice, like there is nothing that you can stop you from being good at it. And in case you feel any doubt even after going through the lecture, feel free to discuss that with your faculty. So that's it from this session. Thank you so much. See you all in the next one. Goodbye.